In this lesson, we'll be discussing lambda expressions, map, and filter. Map and filter are built-in functions in Python that allow you to efficiently apply functions to every element in a list. Lambda expressions are useful in this context because they also allow you to create functionality without the full formal syntax of a normal Python function. Let's open up a Jupyter Notebook and explore these functions in lambda expressions. Let's begin by talking about the map function. The map function allows you to map a function to an iterable object. That is to say, you can quickly call the same function to every single item in an iterable, such as a list. For an example, let's create our own function called square, which simply takes in a number we'll call num and returns that same number to the power of 2, or squared. Now, if we had a list called my nums, or my numbers, and it was numbers 1, 2, 3, 4, 5, and I wanted to apply this function to every single item in this list and then create a new list out of it, one option would be to create a for loop, create a new list, and then with a for loop, go through every single number in that list and then append the new result to my new list. Or the other alternative is I could map my function. So I could call map, pass in my function, and then pass in my iterable, or my list. And if you do Shift Tab here on this function, and let's make sure we spell our function correctly. If you do Shift Tab, you'll see that it takes in a func and some iterables, and then it creates a map object. So it makes an iterator that computes the function using arguments from each of the iterables. So let's go ahead and explore this. If we actually want to see the results, notice it has a map object here. So I can say for item in map print the item. So this is essentially generating every single square of this list. So it's applying this function square to every single number in this list. 1, 2, 3, 4, 5 results in 1, 4, 9, 16, 25. If you just wanted the actual list result, you could just pass in this map function into the list, and then you would get the list back out itself. So the functions can be as complex as you want as long as they just return a single item that you can easily map to. So for example, let's create a more complex function called splicer. It takes in some string, call it myString, and if the length of the string happens to be odd, so we check if the length of the string mod 2 is equal to 0, then we return this even, the word even, or the string even. Else, let's go ahead and return the first character of the string. So we'll say myString 0. So this is a more complex function, but it works just the same. We can have a list called myNames, where we have A, BB, we'll say CCC, and then DDDD, and we can say, show me the list when you map the splicer function to myNames. And you can see we get back A, even, C, even. So it's just returning back even if the length of the string was even, or just the first letter of the string if it's odd numbered in length. And notice what we're doing here. This is something interesting. We are just passing in the function itself. We are not calling the function. So we're not actually calling the function or executing. Instead, we just pass in the function. And the reason for that is because map itself is going to be doing the calling. So we don't want to have parentheses here, otherwise you'll get an error. Instead, what you want to do is just pass in the function itself. So keep that in mind as you use the map function. Let's now move on to discussing the filter function. The filter function is similar to the map function, except instead of applying that function to every single element in the array and then returning the result, instead you're only going to apply functions that return a Boolean value, true or false, and then you're going to filter out the iterable list by the elements that return true when passed into the function. So let's explain this through an example. We will say our function is check even, and it takes in a number, and then it's going to return that number, mod 2, equals 0. So what that means is if I call my function on a number, such as 10, it's going to return true because it's an even number. If I pass it on an odd number, it's going to return false. So all this function does is it returns a Boolean value, true or false, if the number is even or not. Now imagine I have a list of numbers, such as nums, and we'll say this is 1, 2, 3, 4, 5, 6. So I only want the values where this returns true. Well, what I can do is I can use the filter function, pass in my function that returns a Boolean value, and then pass in my iterable object, the numbers. And then if I'd like to see the results, I can pass this whole thing into the list function, and there now I only see the even numbers. So the idea of filter is that you pass in a function that returns Boolean values, true or false, and then you pass in some iterable, almost always a list, and then you filter out the results, and you only get the values or the elements in this list that return true when passed into this function. So that's how the filter function works. And finally, let's discuss the Lambda expression. It's a very useful tool, and sometimes for beginners it's a bit confusing because it's just presented plainly at first instead of showing you how we derive the Lambda expression. What the Lambda expression does, it allows you to create what are called anonymous functions. And this basically means that we can quickly make ad hoc functions without needing to properly define a function using the def keyword. So Lambda's body is essentially just a single expression instead of a block of statements. To show you how we derive the Lambda expression, let's first start off by creating an example function. So just like any other function, we start off with the def keyword, the name of the function, any parameters it takes in. We say result is equal to num to the power of 2, and then we return that result. So here we have our square function, and if we call square, we get back 16. So the square of 4 is 16. Now we can simplify this further because technically I don't need to save this result right here. So I'm going to simplify this by getting rid of this assignment of result and then cutting this and pasting it here. And let's delete this line. And now if I run this again, let's run it now on 3, it still works. 3 times 3 is 9. And in fact, we can actually simplify this further. You could technically write this all on one line. It's definitely not recommended given the syntax of Python or the convention of using whitespace, but this technically still works. If I run this again, pass in another number such as 2, I still get the result of 4. So here I'm saying the square of this number, return the number squared. This is the format of a Lambda expression. So the Lambda expression, what it does is it gets rid of def because you don't need that special keyword anymore, and it also gets rid of the name of the function because the intention is to only use it once. And since you know it's a function that has to return something, you also get rid of the return keyword. And then, so that Python knows that this whole thing is a Lambda expression, at the very beginning of it, you say lambda num, and then num to the power of 2. So this is the form of a Lambda expression. So why would you need a Lambda expression? Well, take a look at these functions right here, such as filter and map. In map, we were applying functions that were defined with def, like square and splicer, and in filter we were defining functions as well with def and then applying them to iterables. Imagine in a very long script you were only going to do this filter command or this map command once. If you were only going to do it once on an iterable, it may not make sense to go through the entire effort of defining a function with a name. Instead, you may just want to pass in a one-time anonymous expression. And that is the Lambda expression. And the reason it's called anonymous is because we never really gave it a name. All we said was Lambda and then the expression, and it essentially has a one-time use case. So I could do the following. I can say map, the Lambda expression we just created. We'll say lambda num colon num to the power of 2, and we're going to map that Lambda expression to some list. And let's go ahead and pass in a list 1, 2, 3, and then we're going to transform this to a list so we can see the results. And here I can see 1, 4, 9. And remember that we can call these variables whatever we want. So this could have been x and x to the power of 2. And if we run this, we get back the exact same result. So it's really up to you what to call this variable, just as it's up to you what to call these variables inside these function calls. So if you just begin seeing Lambda expressions like this right off the bat, it may be confusing at first. But I think seeing it from the derivation of a function makes it a lot easier to understand. Let's go through a couple more examples of lambda expressions. So let's review that lambda expression format for trying to filter even numbers. So we will say filter, and the lambda expression is taking in an n, and then it's returning whether or not n mod 2 is equal to 0. And then we apply that to some list. So we'll say 1, 2, 3, 4, 5, and we'll pass this and transform it into a list so that we can see the results, and it only returns the even numbers 2 and 4. So that's the lambda expression for the function we created up here called check even. And we can see that we can basically create the lambda expression right here. If we just get rid of this, pass in lambda, get rid of that parentheses, get rid of this return, there's the lambda expression that we just created. So if we take a look at this, scroll down here, that's the exact same thing, except we're using n instead of num. But again, you can call this variable whatever you want. Let's see how we would create a lambda expression for grabbing the first character in a string. You would say lambda, the string, and then return the first element in that string. So that would be a way of grabbing the first character in a string. If you wanted to reverse a string, what you could do is say lambda, take in the string, and using slicing notation that we discussed earlier, you could do something like that that reverses a string. And you can even pass multiple arguments into a lambda expression. Again, you can keep in mind that not every single function can be translated into a lambda expression, nor should you try to redefine every single function as a lambda expression. If you ever find yourself having difficulty transforming something into a lambda expression, just go ahead and use the function format. It's really almost always just as efficient to create the full function instead of trying to boggle your mind getting the lambda expression to work. But as an example of a lambda expression that takes in two variables, you could say lambda x comma y, so those are the two parameters it takes in, and then you could say x plus y, and that would be an example of a lambda expression that takes in more than one argument. And that's more useful for other libraries that you may be working with outside of the built-in libraries for Python. All right, that's it for lambda expressions, map, and filter functions. We'll see you at the next lesson.